Hello there and welcome to another episode in my Citroen Relay van build series. In today's video I thought I would share with you how I am designing and wiring up my electrical system and go through some of the products I am going to be using. So my electrical schematic here I've split into three different sections. In the middle here we have our battery storage and our distribution system. On the left hand side we have our charge sources to charge the batteries, and on the right hand side we have our loads, our 12 volt loads and our two 30 volt loads. So I'm going to start at the batteries. So in order to use our electrical devices and appliances in our van, they need to be powered, and we need some way of storing that power so it's available to use on demand when we need it. This is done using batteries, in particular something called leisure batteries. They do vary and are different from starter motor batteries, the battery that would be on your vehicle. They essentially come in two different varieties. There's AGM batteries and there's lithium iron phosphate batteries. In this video I'm not going to go into a lot of detail on the differences of AGM versus lithium and the pros and cons of the two different types, but for my particular installation in my van I've decided to go with lithium batteries. I'm using batteries from a company called Renogy, and these are 100 amp hours each. Being a lithium battery, I do actually get to use that whole 100 amp hours, which in AGM batteries you don't because of the depth of discharge. And in order to have enough capacity for our requirements in our van, because we do want to be able to go off-grid for several days at a time, I've decided to go with 3 batteries linked in parallel. So that's going to give me 300 amp hours of capacity. When linking multiple batteries together, they should always be connected in parallel. So you connect the positive from one battery to the next and then to the next. And again with the negatives, you connect the negative from one battery to the next one and then to the next one. And then when you come out of these batteries to go to either your bus bar or directly to your blade fuse holder, or however you are connecting your system, you should always take the positive feed from one end of the battery stream and the negative feed from the other end of the battery stream. What this does is it allows for an even usage of power across all 3 batteries. One aspect I liked about the Renogy batteries in particular was this battery monitor. Now, normally when you are connecting batteries in a camper van, you want to be able to check on your voltage and your amperage and lots of various information, which is very useful to just keep an eye on how the batteries are performing and the condition of the batteries at any given time. One of the most popular methods of doing this is using a Victron BMV shunt, which is a shunt which connects onto the negative output from the battery stream and then connects to a little display panel to show you this information. With the Renogy system you don't need a shunt because this little battery monitor actually connects directly into the battery using an RJ45 cable, so there's no shunt required. This allows for a much easier and simple installation, and also this is considerably less expensive than the Victron BMV shunt. I have calculated, because I have 300 amp hours of capacity, that I am going to need to connect these batteries together with a 50mm cable, and then the connection on from there into my distributor also will be a 50mm cable. And I'm going to install a master fuse straight at the battery on the positive connection here with one of these types of fuses with a cube fuse in there, rated appropriately for the batteries. So now we have our batteries set up and connected and fused. We need some way to actually charge these batteries. So we need to look at our charge sources. So starting at the top here, in my van I am going to have solar panels connected together on my roof, and I'm going to be using 3 solar panels. These also come from Renogy and are 160 watts per panel. There's a big debate about whether you should connect these in series or parallel. I've chosen to connect mine in series. By doing this, the combined voltage of the 3 panels is added together, but the ampage stays the same. Therefore you can use smaller cable sizes. If you were to connect these in parallel, the voltage would remain the same, but it would add the amps together of each panel, so you would need more connections and a larger cable size. So I've decided to go with the series connection option. And what you do is you connect the negative from one panel to the positive of the next, and then the negative from that panel to the positive of the next one, and so on, and you create what effectively is a daisy chain. Although it's often said that you don't need to add a fuse if you're connecting solar panels in series, I like to approach these things from a belt and braces point of view. So I am going to add a 15 amp fuse on a special MC4 connector to my system, which is going to be outside. And how I've come to this calculation for this fuse here is according to the instructions for the MPPT charge controller. You should take the optimal operating current of the solar panel, which in this case on the Renogy 160 watt solar panel is 7.92 amps, and you should multiply that by 1.56, which is the sizing factor, which gives you an ampage of 12.35, and then rounding that up to the nearest available fuse is a 15 amp fuse. Even though the operating current of one of these panels is 7.92 amps, bear in mind, because I'm connecting these in series, I'm increasing my voltage, but I'm not increasing my ampage. So even though there's 3 panels, we are still operating at 7.92 amps. These cables will go through a cable gland on the top of the vehicle and will then come in to my double pole isolator switch. The cables that Renogy supply are 6mm cables. The double pole isolator switch will disconnect both the positive and the negative at the same time. Therefore, if I operate this, I'm isolating the solar panels completely from my MPPT charge controller, so that I can carry out any maintenance or changes quite safely, knowing there's no voltage or current running to this. So on the charge controller, I've gone for, again, a Renogy product. This is a 40 amp Rover Elite MPPT charge controller. It's a nice simple device. There's an LCD display on the front of the charge controller. The positive and negative connections from the solar array come in here, and there's a positive and negative connection. This does come with a temperature sensor which connects into the charge controller, which you place with your batteries. That way it can keep a watchful eye on the temperature of the batteries and adjust the charge controller accordingly. With lithium batteries, this is particularly important both on high and low temperatures, because although lithium batteries have many advantages over AGM, the one disadvantage they have is they don't particularly like really cold temperatures. So by having this temperature sensor connected, if it does get exceptionally cold, the charge controller will recognize that and will stop trying to charge the batteries and cause any damage. The Renogy Rover Elite MPPT charge controller also has a dedicated LCD display panel, which again connects with an RJ45 cable like the one on the batteries, and this allows you to mirror the information here that you would have here. So in the habitation space of your van, you can keep an eye on what's going on, what state of charge you have, how many volts and amps are going into the batteries at any given time. I have my MPPT charge controller connected into my distribution system using a 16mm cable as recommended in the instructions from the Rover Elite charge controller. Moving on, my next option I have for charging my batteries is my DC to DC charger, which is the charger that connects to the starter battery in the vehicle. I have a fairly new Citroen Relay, which is a Euro 6 rated engine with a smart alternator, so the older style split charge relay system won't work with my van, so I need to have a DC to DC charger. So rather than this connecting directly to the alternator as it would on older vehicles, this actually connects to the starter battery, and when we come off of the starter battery, again following the recommendations in the instructions, I'm going with a 16mm cable. It's going through a fuse, which is a 60 amp fuse as described in the instructions, and an isolator, so I can turn it off and isolate it from the starter battery if I choose to. This will then output to the Lynx distributor, and again with a 16mm cable, and this is a 40 amp DC to DC battery charger. The final option I have for charging my batteries is in many ways my emergency backup option, which is a 230 volt mains charger. For this I've gone with just a little small Victron Energy 20 amp charger, which is not terribly big for the size of my batteries, but like I say, it's just my emergency backup option. And this one I'm just connecting directly to the battery as opposed to going through my distributor, and I'm going to add an inline blade fuse there, which is going to be rated at 30 amps. And this will plug in directly to a socket by my consumer unit for my 230 volt input, where I can turn it on and off as I need. This also has a Bluetooth connection, so I can monitor this on my phone of how well that's performing and the charge level going into the batteries. This also can be set up for different battery types, and it does do lithium-ion batteries, so that's going to do the job nicely, I think. That completes the input charging options, and as I mentioned on the MPPT charge controller and the DC to DC charger, they are connecting into my Lynx distributor. So let's have a look at that now, and let me explain what that is. The Victron Energy Lynx distributor is essentially a fused bus bar. What this allows you to do is to connect your charging inputs and your loads on the outputs to just one communal bus bar. I like to think of it as the sort of main hub, the sort of heart of the system, if you like. So from my batteries, my main battery cable is going to come in onto these end connectors here, where my master on-off switch is going to be, and then inside I'm going to have my charge sources coming in on this side, and my loads coming out on this side. Inside the distributor, it is essentially just one big bus bar, so there isn't an input and output as such. I just thought this would keep for a nice tidy installation. So you have your positive bus bar across the top, and you can connect mega fuses in here of various amp ratings, and then this is where your positive cables from your chargers and the positive cables from your loads will connect. And then underneath is your negative bus bar, where the corresponding negative cables will connect as well. So this just keeps the whole system nice and clean and tidy with everything together in one place. I've decided to go for this system with mega fuses, as opposed to using lots of separate breakers and fuses. Although they work very well, it does make for or can make for a somewhat messy and untidy installation. And although I appreciate with breakers, if it was to trip, you can just reset the breaker, where with this system you'll actually have to replace the fuse with a new fuse. The reality is I don't think these things actually blow and break very often, and these things are only pennies each, so I'm just going to take a selection of spares with me everywhere I go. So that completes the main distribution or the main hub of the system, which is this links distributor. Now let's move on to the load side of the system. So first of all, I have my 12 volt loads. So from the links distributor, I have a cable coming to my 12 volt blade fuse holder. I'm going to fuse that with a 50 amp mega fuse, and I've decided to go with a 16mm cable. In reality, I think I could have used a smaller cable. A 10mm would have been more than adequate for this, but at the time of buying all the equipment and buying the cable, I actually found that the 16mm was just as inexpensive as the 10mm cable. So I bought a larger roll of 16 because I needed that for many other connections, and have used that for this connection as well. I think the sort of golden rule, if you like, is if in doubt, always go up a size or two, never go down in size. So it never hurts to use a cable that's a bit beefier and chunkier than you actually need according to your calculations. It's never going to hurt. The reason why we have a fuse here, as well as having blade fuses here, is the fuse in the links distributor. The purpose of that is actually really to protect this cable, and the blade fuses here will protect the appliances and the devices. So I haven't listed everything that I'm going to be connecting here, because there's far too much to put on this diagram and it'll just look a bit messy, but I've cherry picked a few of the more obvious ones. So working our way around, we're going to have our water level gauges connected. This will just need a small 1.5mm cable. We'll have USB sockets in the van, which again, a 1.5mm cable will be adequate for that. I'm going to have two max fan roof fans, and again the 1.5mm cable is plenty for that. I'm going to have various lighting circuits. I'm going to have a 12 volt compressor fridge. This does need a bigger cable, and although the recommendation is a 6mm cable, I'm actually using a 10mm cable, because again I had some 10mm cable available and it was long enough to make this connection. And like I said before, working on the basis of it never hurts to be bigger rather than smaller, so that's what I've decided to use. Then we have extra connections, things like a 12 volt connection to the toilet for the flush, and the connection to the water pump, which would be 1.5mm. Like I say, there are some other connections to this, but that just gives a general overview of the sort of things you'd connect to your blade fuse holder. And then what you do is, for each individual appliance or set of appliances, in the case of your lighting circuit, is you work out what the amp rating for each individual thing will be, and then you put in the appropriate size fuse into the blade fused holder. These are the same types of fuses that most cars use, so they're very inexpensive and readily available. And again, you always sort of round up with these fuses. It's always a good idea to allow for a bit of extra leeway with these fuses. I always think 25% is a good option. So you take the amp rating of the appliance, you add 25% to that by multiplying the amp rating by 1.25, and then whatever that comes out at, you then round up to the nearest available fuse size from there. So on my 230 volt load side of the system, I have a Renogy 2000 watt inverter. This has a built-in transfer switch, which is a nice feature and saves having a separate one. I'll explain in just a second how that is going to work. But this is connected to my Links distributor with a 25mm cable, which is what Renogy recommend, and actually that cable comes in the box with the inverter, so that's absolutely fine. My consumer unit here will take a connection from the shore power or the hookup on the campsite, and will come in, and then from this 230 volt consumer unit I will have a direct connection to a socket where the 230 volt mains charger will be plugged in. I'm also going to have a direct connection to the Truma boiler and a direct connection to a specific socket in the kitchen where we are going to have a small microwave and a portable induction hob connected. I also have a connection then into the back of the Renogy inverter. So what's going to happen is when we are connected to a shore power connection or a campsite electrical hookup, is I'm going to have my 230 volt feed to the socket, to the microwave and the induction hob, and also to the mains power input on the Truma combi boiler. The Truma combi boiler will run off mains or gas or a combination of the two. This can be run when I have a mains hookup. And then the connection that goes into the inverter will recognize this mains input, and it has a changeover switch, as I mentioned, which is a mains power priority changeover switch. So when there's mains coming in here, it will simply loop that mains connection through to the output sockets, which will then go to the rest of the sockets in the van, which is where we'll plug in things such as phone and laptop battery chargers, the battery charger for our drone and our golf cart batteries, and possibly a toaster and various other bits and bobs like that. So how this system effectively is going to operate then with this type of connection is when we have an electrical hookup, I'm going to have all of these items available to me, not necessarily to use all at once, of course, because the electrical hookups and the campsite hookups only have a certain amount of amperage invariably, but there's going to be power running to everything. When we're off grid and there's no electrical hookup, what's going to happen then is this dedicated socket in the kitchen where the microwave and induction hob are connected will go dead, and we won't be able to use those appliances, and we'll just make do with the gas hob for cooking facilities, and that will be fine. And also the Truma boiler will lose its mains connection, so we'll just run on gas only as opposed to a combination of the two. And then there will be no connection into the inverter, so the inverter will still operate, of course, but what it will do then is change over automatically internally, and will take its 12 volt feed from the batteries up that to the 230 volt AC, and then still output that to the sockets where our smaller pieces of equipment will still have power and can be connected. I wanted to do it this way as opposed to the other method where everything can be run off the inverter or the electrical hookup with a manual changeover switch, because although I'm quite comfortable and confident to remember and bear in mind the limitations of the inverter and what you can and can't use at any given time, we do have children in the van, and there's always going to be that possibility, of course, that the children will switch things on and very quickly and easily go over this 2000 watt capability of the inverter, and before you know it, the inverter's gone fizz pop and you end up with a very expensive repair. So I've decided to connect it using this method, just for a little bit more protection of the system and for belt and braces on what can and can't be used depending on whether we're on an electrical hookup or not. So I think that just about concludes my electrical design and how I'm going to be wiring everything together. I hope you found that interesting and informative. If you have, then please do consider to press that like button and consider subscribing, and then you can look forward to the future videos as I make them. In my next video I'm going to be concentrating specifically on this links distributor, on what that is, how it works, and more importantly how there's a little hack you can do to use a links power in as opposed to a distributor and achieve all the same functionality that this has as a standalone product. And I think that just about sums it up for this one. So I hope you've enjoyed that video, and we'll see you next time round. Bye for now.